Hi, this is the Science Chef. This is the last part of a series on our solutions to the October-November 2019 Cambridge IGCSE Chemistry Paper 4. Today we'll be answering the last question, which is question 5. If you'd like to watch our solutions to questions 1 to 4 of this paper, we've added the links in the description. If you'd like to join our membership club to gain access to exclusive videos, live chats, and our live tutorials, kindly click on the join button next to the subscribe button. So let's start. Question 5. Question 5 says methanol, CH3OH, is a member of the homologous series of alcohols. So let's underline the keywords. Methanol, member of the homologous series of alcohols. Okay, first off, before we continue, what is a homologous series? Homologous series is a family of organic compounds that follow a regular structural pattern in which successive members differ in their structure by the CH2 group, or what we call the methylene group, or a mass of 14, right? That is a homologous series. Now, the homologous series we are talking about is what? The alcohols, and the alcohols have the general formula CN H2N plus 1 OH, which is one of the characteristics of homologous series. That's ROH, where N is greater or equal to 1. We are told that methanol can be made from methane in a two-step process. Step 1, methane is reacted with chlorine gas to produce chloromethane. Okay, react methane with chlorine gas to produce chloromethane, CH3Cl. Step 2, chloromethane is reacted with sodium hydroxide to produce methanol and one other product which is not named here. Okay, now what conditions are needed in step 1? Now in step 1, we get chloromethane from the reaction between methane and chlorine gas, right? Methane is an alkane, that's CN H2N plus 2, right? Where N is greater or equal to what? 1. And methane is what? CH4 is an alkane, right? And when alkanes react with, let's say methane reacts with chlorine is a halogen, right? So when a halogen reacts with an alkane, a haloalkane is always what? Formed. So let me write that here first. Alkane plus halogen will give us what? A haloalkane. Right? Now, depending on the type of halogen and the type of alkane reacting, the product will be what? Different. The haloalkane will be what? Different. So when chlorine is reacting with methane, the haloalkane forms what? Chloromethane. But this reaction does not just occur on its own. It occurs in the presence of what? Sunlight or UV what? Light, right? It's a 3-step reaction. There's the initiation stage, there's the propagation stage, and there's a termination what? Stage. That's more complex than your what? Scheme. Fine. So, but for this scheme, we are asked to state the conditions under which step 1 occurs. That's methane is reacted with chlorine gas to produce chloromethane. From this reaction, this will give us what? CH3Cl plus what? HCl. So condition, presence of what? Presence of sunlight or UV light. It's a photochemical reaction. Write the chemical equation for the reaction which occurs in step 1. Wow, that's what we did here. Okay, that's CH4 plus Cl2 to give us what? CH3Cl plus HCl. Now this HCl is a gas. It's a gas, not an acid, not hydrochloric acid. It's hydrogen chloride gas. Okay, now if you are wondering how I got the formula for methane, right? I gave you the formula of alkanes here, general formula. So met here Met means what? One carbon what? Atom. So when N is 1, this formula reduces to CH4. If you want to learn more about naming organic compounds or writing the formula of organic compounds, then watch our video on naming of organic compounds and naming of hydrocarbons. Okay, so we are now then asked to state the type of organic reaction occurring in step 1. Actually, this reaction is a typical reaction. Sorry, I need to add this UV like yes. This reaction is a typical reaction of the alkanes. It's one of the chemical properties of alkanes. That's substitution reaction. And the substitution reaction, one of an element replaces the atom of another element from what? From a compound. As you can see here, a chlorine atom replaces what? A hydrogen atom from the what? Methane, right? Now that hydrogen atom replaced or substituted by the chlorine atom then combines with the second chlorine atom to form hydrogen chloride gas. Now this is not a displacement reaction. No, it's not a displacement reaction, it's a substitution reaction, because chlorine replaces hydrogen in what? Methane. One of the hydrogen atoms in what? Methane. So the replaced hydrogen now combines with chlorine to form hydrogen chloride gas. If it were to be a displacement reaction, then the hydrogen, right, displaced from the methane will not combine with any other thing to just exist as a molecular hydrogen gas. That's H2. Complete the chemical equation for step 2. Okay, step 2. What happens in step 2? Chloromethane is reacted with sodium hydroxide to produce methanol and one other product. So from here, what is happening here? We have CH3Cl plus NaOH giving us CH3OH. So this OH here combines with the methyl group here, right, to form methanol. Well, it means that the sodium ion here will combine with the chloride ion here to form NaC, sodium chloride. Is it balanced? Yes, it's balanced. Now draw a cross and dot diagram to show the electron arrangement in a molecule of methanol. Draw a dot and cross diagram to show the electron arrangement in a molecule of methanol. Show outer shells only. Fine. We are interested in outer shells. So which means that here now, before you can do this, let's draw out the structural formula of methanol using bonds. So you have C, there's only one carbon there. 1, 2, 3, right? CH3OH. So that O is between carbon and what? Hydrogen. Fine. Now, in this structure, you can see each single bond is made up of 2 electrons. That's a pair of what? Electrons. And we are told to use cross and dot diagrams. Now we have 3 atoms here, which means that we have to use more than 2 symbols. First of all, use the cross for the carbon. You can use it for any other element or atom. It's up to you. But I want to use the cross for the carbon. I use the dot for hydrogen, and then let's say square or rectangle for oxygen. So, like we said, that each bond here is made up of what? 2 electrons. So, since the covalent bond, it means that the electrons were what? Shared or unequally what? Contributed. So, which means that hydrogen here, this hydrogen will bring 1, while the carbon atom will bring 1. Same thing here. Same thing here. That's for this. This is for this. This is for this, and this is for this. Fine. So now the bond between carbon and what? Oxygen is a single bond. So that carbon will bring its cross electron, while the hydrogen will bring the what? The triangular or rectangular what? Electron. Then we are now left with the what? The bond between oxygen and hydrogen. Oxygen and hydrogen. So oxygen will bring its rectangular electron, while hydrogen will bring its dot electron. Good. So now, after we have done that, remember we are asked to show what? Only outer what? Shell electrons. So hydrogen here, the outer shell electrons now what? 2. 1, 2. So hydrogen is complete. The essence of bonding or the chemical combination is to attain the noble gas configuration. So oxygen here has attained the duplex configuration 2, 1, 2, correct? 1, 2, complete. Now this carbon now has what? 1, 2, 3, 4, 5, 6, 7, 8. So it's checked, correct? Now this other hydrogen also has what? 1, 2. So all the hydrogen and carbon atoms are what? Are completely filled, right? Now oxygen has 1, 2, 3, 4. It's meant to have what? 8, because its configuration is what? 2, 6. It has 6 electrons in the outermost shell. But from what we have here, we have only 1, 2. That's 6 electrons in the outermost shell before bonding. So after bonding, it's meant to have what? Plus 2. It's meant to have what? 8 what? Electrons in the outermost what? Shell. But how many does it have here? 4. So that there are other 4 electrons we've not accounted for, and those 4 electrons were not used in what? Bonding. So we add them here, and since they were not used in bonding, we call them what? Lone what? Pair, or lone pairs of electron, as the case may be. So that's that. So these 2 marks, how will we end these 2 marks? 1 mark will be for the correct bonding and use of what? Symbols for each what? Atom in all these bonds. This. When once you get all this correctly, that will be what? 1 mark. Then these lone pairs, the complete outer shell electrons for oxygen, will also be what? 1 mark. The next question here says, question 5C says, methanol reacts with propanoic acid to form an ester with the molecular formula C4H6 H8O2 C4H8O2. Methanol reacts with propanoic acid to form an ester, okay, with the molecular formula C4H8O2. Now this reaction is what? It's known as esterification. And what's esterification? Esterification is a reaction between alcohols and carboxylic acids to form esters and water in the presence of mineral acids. The presence of mineral acids, and the commonly used mineral acid is concentrated H2SO4. The commonly used mineral acid is concentrated H2SO4. It is actually a reversible reaction. It's a reversible reaction, and it's very, very slow. So we have alkanols plus alkanoic acids or carboxylic acids, we call it that way. One reversible reaction to give us what? Esters and water. So there are always 2 products, esters and water, right? So which means that the only constant product here is water, right? The esters form will depend on the what? The type of alkanol and alkanoic acid that are what? Combining. So here we are told to name the ester formed when methanol reacts with propanoic acid. So methanol, let's see. Before you name it, first of all write the form. You know how to write the formula. Methanol is CH3 OH plus propanoic acid from the formula CnH2n plus 1 COOH, where N is greater or equal to what? 0. So for propanoic acid, N will be greater than what? Will be equal to what? 2, because it's already 1. This is already 1. This is the first carbon atom. So you need 2 more carbon atoms for propan. Prop is 3. So that will be what? That will be C2H5COOH. So that is just 3 carbon atoms here. So that will be C2H5COOH. Now in forming this product, this part of the acid, organic acid or alkanoic acid, will first of all be written first as C2H5CO, then while this other part of the alkanol will be written last. That's what OCH what 3. Then this OH and this hydrogen will then combine to form water. Are we together? So now, which means that generally, if you were to write this in a formula, I will call this ROH plus R prime COOH, right? To give us what? The presence of an acid to give us what? R prime CO, right? R prime CO, because this one first go and then this one will then come COOR plus what? H2O prime. Which means that when you're writing the formula of an ester, the alkanoic acid component comes first, right? The formula from the alkanoic acid component comes first, while the part of the alkanol comes last. The part of the alkanol comes last. This is the alkanol. So this R here is from the alkanol. Alkanol. That is R here. R prime is from the what? From the acid. And when you are naming esters, esters are named as alkyl alkanoates. Alkyl alkanoate. This alkyl is from the alkanol, while this alkanoate is from the alkanoic or carboxylic what? Acid, right? So, like methanol and propanoic acid, the methanol will form the last part of the what? Ester in terms of the formula, right? While the propanoic acid will form the beginning part, right? Initial part of the what? Ester in terms of the formula. But when it comes to the name, you name the alkanol first before naming the what? The ester. So the alkyl form of methanol is what? Methyl. That is METH what? L. While the alkanoate form of propanoic acid is what? Propanoate. Propanoate. So the name of the ester formed is what? Methyl propanoate. Methyl propanoate. Now name one other substance formed when methanol reacts with propanoic acid. No other substance formed when methanol reacts with propanoic acid. And I said from this reaction, in esterification reactions, the only constant product that is always formed is what? Water. The ester will always change. The ester can always change depending on the alkanol and alkanoic acid combining, right? So since you already know the ester that is formed, right, then the other product can only be what? Water. Remember, we are asked to do what? Name. So we will not accept any formula. The next question says, draw the structure of an ester which is a structural what? Isomer of the ester named in CI. In CI, show all the atoms and all the bonds. That's the structure of an ester which is a structural what? Isomer of this other ester. Remember, isomers are their compounds that share similar molecular formula or same molecular formula but different structural formula. First of all, we need to draw the structure of methyl propanoate. This is the molecular formula of methyl propanoate. This methyl propanoate, methyl, this is propanoate, methyl, this propanoate. Okay, so but if you have to draw the structure of an ester to be something like this, R C double bond O R, right? O R. So in this case, R prime C double bond O R. For methyl propanoate, what's the R here? The alkyl group. That is C1, 2, right? Then this C double bond O, single bond O. Then CH3 here. Then CH3 here. That's C1, 2, 3. Right? So we complete the structures here. So to be H here, H here, H here, H here, and what? H here. This is the formula for methyl propanoate. and we want to form isomers of esters. All what we need to do is to exchange the alkyl groups in the formula. So we need that if we bring this one here, and bring this one here, right, we'll get an isomer. In other words, if we do that, we can get something like this: R prime. So provided R and R prime are not the same, by the time you exchange their positions in this structure, you will get a different isomer, right? So which means that for this structure now, we are going to change this CH3 here with this C2H5, right? So if we do that, first of all, the molecular formula will be CH3 COO C2H5, is it not? And by the time we draw the structure will give us what? C. The first C here is this. The second C is this. But the second C is doubly bonded to what? Oxygen. Doubly bonded to oxygen and singly bonded to what? Another oxygen here, as seen here. Then this second oxygen is then bonded to what? C2H5. That's C212. Okay. And then we complete the hydrogen. Good. So this gives us the isomer. This gives us the isomer of this other ester, the isomer of methyl propanose. What will be the name of this ester now? The name of this ester will be 1,2. That's 1,2. That's what? Ethyl, and 1,2 ethanoate. Ethyl ethanoate. That this C2H5 is from the alkanol, as we described here, yes, while the CH3CO part is from the alkanoic acid. So if this is from the alkanoic acid, that's CH3CO. To just complete it, we add what? OH. And if this is from the alkanol, C2H5O, to complete it, we add what? H. So C2H5OH is what? Ethanol, while CH3COOH is what? Ethanoic acid. So from ethanol we get what? Ethyl, and from ethanoic acid we get what? Ethanol. That's the structure of the ester as an isomer of methyl propanoate, as stated in the word question. Remember, we are asked to show all the atoms and all the bonds. Yeah, that is that. And then the last question, we have to state the conditions needed to form an ester from a carboxylic acid and an alkanol. What was the condition here? From what I wrote here, the reaction must be what? Reversible, right? Which means that it must occur in a reflux or in a closed system for it to be what? Reversible. And also there must be presence of what? A mineral acid. So it must be reversible. And presence of what? Presence of mineral acid, commonly what? Concentrated H2SO4. Commonly concentrated H2SO4. Now concentrated H2SO4 here acts as a catalyst, because it's slow reaction, acts both as a catalyst and as a dehydrating agent, because it helps to remove what? Water molecule from the reaction. Can you see reaction? Yes, in the form of condensation reaction to remove the water molecules from the reaction between the alkanol and the alkanoic acid, right? And it also speeds up what? The rate of the reaction. The forward reaction is esterification, while the backward reaction is hydrolysis. So with this, we have come to the end of our solutions to the October-November 2019 Cambridge IGCSE Chemistry Paper 4. If you're able to learn anything from this tutorial, hit the like button and leave a comment. Also, if this is your first time here, don't forget to subscribe to our channel and turn on the notification bell to always stay updated with then you upload, and I can assure you, you will never regret doing that. A wise man once said, "It's not happiness that brings us gratitude, but it's gratitude that brings happiness." So always show a heart of gratitude till I see you when I'll see you.